regions are all of the x's and y's that make this true. Okay. So far okay? All right. The boundary is the line. Okay. The half plane is the shaded portion or the unshaded portion. Even though this doesn't look like it's half exactly, planes go on forever, so if you draw a line through it, it's technically cutting it in half because you're taking something that's infinite and cutting it with an infinite thing, and we just call it half. So this is a half plane and this is a half plane. A closed half plane has a solid line, which is for less than or equal to or greater than or equal to. And an open half plane has a dotted line, which is less than or greater than. Whoops, sorry, didn't mean. So, to graph an inequality, first you put it into the form of y equals mx plus b, only it doesn't have an equal, it still keeps the greater than or less than symbols. Then we graph the line. If we have less than or equal to or greater than or equal to, we use a solid line. And if we have just less than or greater than, we used a dotted line or dashed line. So if I'm drawing my line and it's like y is greater than x, I have to do a dashed line. And if it's y is greater than or equal to x, I would do a solid line. So the equal makes it a solid line and no equal makes it dotted. Because the line is the boundary, and if it's a closed boundary, it includes all the points on the line, make it true. If it's an open boundary like this, the points on the line aren't true. That's just the edge of where you would be true. After we've graphed the line, we pick a point that's anywhere else that's not on the line. Any point we want, as long as it's not on the line, we can use it. We plug those in for x and y, and then we simplify it. If we get a true statement, then we shade the side that had that point, and if we get a false statement, we shade the side that didn't have the point. We shade the other side. Okay, so I'm going to walk through that while we actually do it so it'll make more sense. So step 1, I'm going to put this into y equals mx plus b, so I'm going to move the 3x over. And so now it's negative. Then I'm going to divide everything by -1, and the reason I'm going ahead and showing the division instead of just changing all the signs is because what happens to an inequality if we multiply or divide by negative? Do you guys remember? Yeah, we have to flip it, so that becomes greater than. So just be careful of that. If you have that negative y, you have to flip the inequality. Okay. Now that I've got that, I'm going to graph this line. Because I'm just greater than, it's going to be a dashed line. So I put my point at -2, and my slope is 3. So I'm going to go up 3 and over 1, because 3 is the same as 3 over 1. So I go up 3 and over 1, up 3, over 1, up 3, over 1. And then, I would recommend using a ruler for this part if you want. And we're going to make a dashed line. That's my boundary. Okay. I'm just going to move this over a little bit. Now I can pick any point I want that's not on the line. Whenever humanly possible, I like that point right there, because that point is 0, 0. So I'm going to plug in 0 for y and 0 for x, and that makes everything really nice. So I'm going to do that. I've got y is greater than 3x minus 2. I'm going to plug in 0. 0 is greater than negative 2. This is true. So because it's true, I'm going to shade the side that had the 0 on it. And you don't have to be pretty, just some sort of shading. I don't grade for perfect shades. Okay, if it was false, if this had been a less than, and so it said 0 was less than negative 2, I would have shaded the other side. So if it's true, you shade the same side. If it's false, you shade the other side. Now this one is already in y equals mx plus b, but it doesn't look like it. But you see y and mx and b, we just have to kind of move things around. So I'm going to flip it. And because the arrow was pointing at the y here, it's going to point at the y there. Now it's in y equals mx plus b. My slope is 1. So I start at negative 1 and I go up 1 over 1. And these are so close together that really I could just make this my line. See? And my favorite point is still available. If 0, 0 is not available, I like to use 1, 1. Also very easy. Or like negative 1, 1 or 1, negative 1. But you can use, I could use like 6, 3 if I wanted to. I can use any point I want. I just can't use any point on the line. So I can use any of these points over here. I can use any of those points there, just not on the line. So if I plug in 0, I get 0 is less than negative 1. True or false? False. Because 0 is greater than negative. So I'm shading the other side. And like I said, I could pick any number. So if I had picked, what are you doing? If I had picked 6, 3, which would have been that point right there, I would have plugged in 3 is less than 6 minus 1, which would have given me 3 is less than 5, which would have been true, and I would have shaded that side. So you can pick in any point. Any point in the shading will be true, and any point over here not in the shading would be false. These have the less than or equal to or greater than or equal to, so I can use a solid line. I still have to put them into the correct format. So I move that x over, it's now negative. Divide by 5. I get y is less than or equal to negative 1/5 x plus 2. So I'm going to start at 2, and I'm going to go down 1 and over 5. 1, 2, 3, 4, 5. And this time I can draw a solid line. Close enough. Pick any point. Well, I like 0, 0, so I'm going to keep with that one. So 0 is less than or equal to 2. That is true. So I shade that side. Okay, so I put it into y equals mx plus b. And I've got my line. Which side am I going to shade on? Anybody? Anybody? Well, if we plug in a point, which point would you like to plug in? Recommend that one. That's false, so yes, top part. Inequalities. Now, to graph a system of inequalities is very similar to graphing just a regular inequality. So the first step is to put each equation into y equals mx plus b and graph them. Well, they're not equations, sorry, they're inequalities. Okay, so we graph each line. And I usually do them one at a time. Like I go step 1, step 2, and then step 1, step 2 again, but you can do this kind of however you want. The second step is to lightly shade, Okay, so we figure out which side to shade for each individual line, and we lightly shade those. And then the final step is to darken in the part where the shades overlap. This is our solution. Okay, so we're going to graph the two lines on the same coordinate plane, shade each line lightly, and then the part where the two shades overlap, that's where we shade dark, and that's the solution. So if I'm going to do the first one in blue, and I'm going to do the second one in red, just so that it's easy to differentiate. So if I graph the first one, I start at 1, my slope is -2, so I'm going to go down 2 and over 1. And then I'm going to go up 2 and over 1, because I like to, and then I make my dotted line, because it's just a greater than. Okay. Now I need to decide which side do I shade. Okay, so if I use my 0, 0 point, I'm going to get 0 is greater than 1. This is false, so I am not shading this side. I'm going to shade this side over here. So I'm just going to lightly shade it. So I'm just going to do stripes to show that that's the shaded side. Then I'm going to graph the second line. I'm going to start at 3. My slope is 1, so I'm going up 1 over 1 each time. And this is less than or equal to, so I can use a solid line, which is going to come like this, except normally I would draw it straight. Then if I pick the point 0, 0, again, I'm going to get 0 is less than or equal to 3. This is true. So I'm shading the side that has 0 on it. So that's this side here. So the whole red line gets this part shaded, the blue line gets this part shaded, and then the solution to the system is where you have both the red and the blue. So I want to darken that in to show that that's where they overlap and that that's the solution. Okay, y is less than or equal to 3. I'm going to do that one in red. So I'm coming up to 3, and since it's a y, there's no slope, so it goes straight across, so it's this line right here. And less than that is going to be anything below 3. So, but if I plug in 0, I'm going to get 0 is less than 3, which is true. So I'm going to shade this part red. Then I've got this part to be blue. So I need to change that. Makes that negative x plus 1. So I start at 1, and then I slope is negative 1, so I'm going down 1 over 1 forever. So I draw my line. I can plug in the point 0, and I get 0 is greater than or equal to 1. This is false. So I'm not shading on the 0 side, I'm going to shade the opposite side, which is over here. And here's where we have the two colors overlapping. So I'm going to come in and shade those darker. Now, some people don't like all that shading because they think it's too messy. And that's fine. There's another way we can do this. I'm going to put that into the y equals mx plus b. I'll graph it. It's got an equal to, so I can draw a solid line. If I plug in 0, 0, I get 0 is greater than or equal to 2, which is false. So I'm going to shade this way. And I can just put a couple arrows just so I know which way I would have shaded. And then I'll do the other line. So I start at 4. My slope is the same, except this time it's a dotted line, sorry. Okay, I plug in 0, 0, and I get 0 is less than 4, which is true, which means I'm shading this way. So the overlap is going to be between the two lines. So I'm just going to shade the in-between. So if you don't like all this shading mess, you can just draw like an arrow to show which way you would shade, and then shade the part, only shade the part that would overlap. Just so you know what happens, when I put this one, I get negative y is greater than or equal to negative 3x plus 2. But I don't want to know negative y, so I have to flip that sign and change all these. So I have negative 2, and my slope is 3, so 1, 2, 3 over 1, 1, 2, 3 over 1. And I have a solid line, and I'm going to go ahead and use my nice, pretty, perfect line drawer. And that would shade this way. Okay. Or if you prefer, we can actually go in and shade. That would shade this way. Then if I do the next one, I get negative y is less than negative 3x minus 5, but I don't want negative y, so I change, everything. And I start at 5, and my slope is 3, which I can't go up 3 over 1, so I'm going to have to go backwards. So down 3 and back 1. And I have a dotted line, and that's okay because I can still use my handy dandy straight line cheating tool. And then if I plugged in 0, 0, I get 0 is greater than 5, which is false, which means I'm going to shade this way. Or if you like the shading, you've got that happening. And there's no overlap. When that happens, you have no solution. Because the solution is where the shades overlap. So if the shades don't overlap, there is no solution.